Hello, today I would be walking you guys through our Arc.flow module, which is our configurable process orchestrator. The concept of Arc.flow is that you can build out as many of these flows as needed to help you react to certain events that can happen in your system so that you can take the necessary follow-up actions. You can see from the main interface here that I've created several flows that help me automate some of my business processes. So the first flow here is the inspection results processing flow, and I'll show you how it works in action later on. But you can see the first thing is that the process of designing a flow is fully drag and drop. This flow has a lot of events and a lot of tasks that it can use, and these events and tasks are the building blocks that makes Arc.flow so powerful and so flexible. An event is anything that can happen in your system and needs to be captured. This can be an incoming request or an incoming event from a third-party system, or it can be an event that happens in our MES system, for example when your product is produced or when your work order is finished. Now these list of events are extendable, but what we provide out of the box is more than enough for your common use cases. The most common one would be this HTTP request event, which is when a third-party system or our system trigger this flow through a REST API call, and this is the modern standard for software integration. So you can see that from my flow here, the HTTP request is actually the triggering point or the starting point of my flow, and this is receiving a post request to a specific URL. After this event has been captured and triggered our flow, then you can build out these process flow to decide what you want to do to follow up with it. You can use these building blocks that you can see in gray here, which comes from a list of tasks that we provided out of the box and can be extended as well. For our out-of-the-box tasks, you can see that we have logic tasks. For example, you can perform if-else condition, looping, forking or joining, as well as executing your custom script in JavaScript. You can also perform HTTP requests to integrate with software system, because this is the modern standard. For messaging, you can send out email. We can also support sending of SMS, Telegram messages, WhatsApp messages. For SQL queries, you can execute to retrieve or save data directly into your SQL database. We also support not only MS SQL database, but any commercially available database out there, and because this is extendable. There are also UI, user, and validation tasks, so a lot of embedded capabilities and flexibilities. This flow that I built here, I'm using several tasks that lets me save data that comes from the HTTP request, split the data, save the data into our database using SQL tasks, and the purpose of this flow is to perform inspection result processing. So before I can show you this flow in action and how it works, a little bit of background context is that we're trying to apply this flow to our lightweight MES system to automate certain processes. So if you're not familiar with this, please refer to our ArcLight introduction video. But if you are, then this is the workstation module that lets you execute on your work order. And in this case, we're working on this work order Arc.flow work order 3 here. This is the list of steps that we have configured and mapped for this work order, which includes picking to inspection of raw material, to approval, to weighing, production, and so forth. If you click into the first step, which is raw material picking here, the first thing you can do is to start or pause or stop the step to record the information of when your step is running. On the right-hand side panel here, you can see several tabs for you to key in information, and one of them is the checklist tab. The purpose of this checklist that I'm opening up here is for you to record the picking results of what raw material batch you're picking for different types of raw material that is required for the step over here. So you can key in the batch number of these raw material as well as the quantity that you're picking, and this would provide information that can be archived and recorded into the system. So now we can submit this information, and then if we're done with the step, we can stop and then proceed to the next step, which is inspection of this raw material. For the inspection step here, there is one checklist that we need to fill out as well, which is when we're performing inspection for these raw material batches that we have picked, what are the inspection results? So you can see that the picked batch of material have been automatically populated here depending on what you keyed in the previous step. But for each of these batch, you need to key in the inspection results, whether it pass or fail, as well as some measure about the inspection, such as consistency and color over here. Now, for example, if you already have an outside inspection system, maybe an inspection machine, maybe operator, maybe some other third-party system that is managing this, and it's outputting certain log files, for example, like the one I'm showing you here, then there is a way for us to automatically capture these log files and use arc.flow to automate the process of keying in that checklist in our system so we can record those inspection result data. The way that we can do that is by using Acquire here, which is the hardware integration toolset that we have. So you can see I've built out one profile here, which is getting data from a file processor data provider and exporting it through a web API. What that means is that it's constantly looking up new files or changes to files in this inspection results folder. Whatever new changes it reads, it will package the message in this format and send to the URL as you can see above there. That URL is an arc.flow URL, and that URL would route and trigger the flow that I've just shown you here, which is the inspection results processing flow. The triggering point is when my data is received. The next thing I'm doing is saving this data that is coming from the Excel file that is processed by Acquire into the flow so that I can process and use it later on. Next thing, I'm splitting the data up so I can inspect different parts of the data and use it in different places. The next thing here is the save and alert, which is a forking task that allow me to split the operation into two different pathways. One is to save the data into our database, to our checklist, and one is to check if the inspection results is failing. So you can see that every task here have an output path or more than one output path depending on the nature of the task. For example, for this forking task here, you can see that there are two output paths, which is save and alert. For this SQL task here, you can see there are numerous output paths. For example, for one that happens when there is no result, there is also one that happens when there's an error, and there is one that happens when it's done. So depending on the task, these output paths would be available in the different numbers. So going back to my checklist here, the overall flow is that after I have saved the data into the database with my one branch, in the second branch I would do a checking for this inspection result here to see whether it passed or failed. If it is not passed, I would send an email to alert myself, and the content of the email is somewhat you can see here. This is in HTML format so that it can be formatted nicely when the email shows up to the end user. So this is the overall flow that we have. So if I start this profile now, which is the inspection results processing flow, what's happening is that this file that I'm showing you guys here would be automatically processed from Acquire and then sent to arc.flow with all the results that it's reading from the Excel log file. So now if I go back into my inspection result checklist, you can see that the inspection results will slowly start to come in as it gets processed by Acquire and arc.flow in combination. So if you load up here, you will see that the first result is already processed and automatically keyed in. Right? This is the results for the first batch of item, which has the past inspection results. So we would only receive an email when there is a fail item in our inspection results. That's why you see there's nothing incoming here. If I reload this inspection checklist again, you should see some updated records over here. And by the time the inspection is fully done, then we should receive an email for the last item, which was failing. So here you can see that the second one has come in with the past results, the consistency of 3.5, and a random color that is indicated on the Excel log file that we have over there. That this happening can be done within less than a second. So the amount of load that this can handle can be quite high. So you can compare these results that we're seeing on the checklist here with the results that we see in the log file, and you will see that it's exactly the same. So now I assume that the processing has been done. So yes, if you go into the email here, you can see that the processing is done, and you can see the email notification coming in that matches with the last fair result that I show you on the Excel file here. So if I go back into the checklist, we should see that all the results has been automatically imported and keyed into our system. So this would not require any manual keying anymore. And this is one example of how we use arc.flow to help automate these processes. Now I've gone ahead and completed the RM inspection step as well as the approval step so that we can get to the weighing step in which we can key in and indicate which batch of material that we're consuming for these raw material type that we have configured is needed in this step. So you can see that we have the ability to add this consumption manually by clicking on this plus button, selecting the batch of material, and keying in the quantity, in which case the system will record this so you can have traceability later on. But in the case where you're integrating with a barcode scanning or RFID scanning system, we can use a combination of arc and arc.flow to automate this as well. So the example that I'm giving you here is using arc and arc.flow with this weighing integration flow to help you automate the scanning process. So the starting point is again an arc profile in which we're using an Ethernet server or a TCP/IP server, and we're exporting it through REST API to arc.flow as well. For this arc profile, we're listening on port 24 of this address, which is our base address, and I can test and show you how this works by using a terminal here that acts as a client, which will substitute the scanning or RFID scanning of QR code scanning. So you can see here that before I run the profile, I cannot connect because there's no server listening on the other side. But if I click on Test Connect Now, then the server will listen and I can connect to this. I can send a payload, which would be received on Arc side as well. So this is how Arc can be set up. So now that is the provider all set. For the refresher, which is how we would use or export this data, again, I'm sending this to arc.flow, which is the weighing integration flow I have over here, is receiving the data as an incoming post HTTP request, similar to how we use for the inspection results processing. In the task I'm doing here, I'm using a custom query to process this data that is coming in to update my database so that my material consumption can be automated. After that, I would return the result of whether the request is valid or not, so that if any other third-party system is using this, they have some indication of the results of their call. So now I'm going to go ahead and start this process weighing data profile. I can connect to this, and now I'm sending a weighing request for work order arc.flow work order 3. I'm sending this batch of material, which is the third batch of material that you have in this inspection results file here. This is the third batch of material that we weighed and picked. So I just copy it and paste it into here. And for the weight of material that I'm consuming from this batch, I'm going to change it to 1.6, and then I'll click send. So the moment I click send here, this is the payload that is going into arc, and it can be captured by arc. And if you go back over here, you can see that has been automatically captured into the system of which batch of material was used and which quantity was consumed. So if for the last batch of material here, I can try and send it in as well, but because the inspection result has failed, the system would actually not let it through, and you cannot consume this failed batch of material. So if you try and put it in here and click send, you will see that the system would receive it still, but if you go back into the list of raw material, there would be nothing. So this is how the system can add additional logic and control through arc.flow as well. Up until this point, I have shown you how arc.flow can be triggered and data can be passed into it to perform several tasks. In the last flow here, I would show you a rather more complex flow to showcase how we can perform our own data querying as well. So this flow have a same triggering point, which is an incoming post HTTP request. But as the request is coming in, I'm forking it into two different execution branch. The first branch here, I'm making a call to a random URL to get data. And this is actually just